Okay, Jyoti ma'am.
Yeah, this is Jyoti. Good morning, everyone. Let me take this privilege to introduce two eminent speakers of the upcoming session. Let me introduce Preetham Mn, CEO and co-founder at Working Labs, Bangalore. He has 17 years of experience in design and development and has skills in development and the productization of embedded products. And he has a vast experience of working in Broadcom, Renaissance Mobile Corporation, Saskin and Global Logic and Rod System, and has the hobbies of photography and trekking. It's nice to have you for the session, sir. And let me introduce another eminent speaker of the session, B.R. Sujata, who is Delivery Excellence Head, TCS Bangalore. She has 22 plus years of experience in software solutions and quality management and has skills of ISO CMMI, Lean Six Sigma Black Belt, customer management and process management. And she also has vast experience of working in TCS, Wipro, Accenture, Fidelity and CGI, and very familiar with the technologies of mainframes and DB2. Her hobbies include chess, throwball, and music. It's pleasure to have you, ma'am, on the session. Thank you.
Thank you. Thank you, ma'am. Good morning, all.
Thank you, Jyoti ma'am. Now we will hand over the session to Preetham sir.
Yeah, let me check, Preetham. I have some issues in network. Give me 1 minute, let me check.
Yeah, I have connected. I will be presenting through a different device.
Okay, great.
So let me.
Preetham, you have not shared the screen still.
Yes, sir. I'll be sharing the screen. So let me know if you have any audio issues, and also let me know if you're able to see the screen.
We can see the presentation, sir.
Okay. Yeah. Sorry for all this fuss. So I have a network problem specifically on this day. So yeah, to start with, so first thing is a disclaimer. I just want to let know that I have used a good amount of images, data, content from internet, and the copyright and intellectual property of each of it remains with their own owners. And this collaboration of and collection of data that I have done is for education purpose only, so that we are clear on this. So moving forward, the main topics that I'd be covering for the day would be a brief of what is IoT. I think Suresh sir tried to cover that. So I'll be just talking about the brief of it from the technical perspective and the device perspective specifically, and little bit of use cases. And more concentration will be on the IoT gateway. So meanwhile, we'll talk about each node also. When we say gateway, it's not just the gateway level, but on the node, how it will, IoT node, what it is, and how it will grab data and everything. IoT integration types will be on how it can be, once you create a gateway, once you create a node, how it gets integrated with the cloud or the server side, and some of the use cases where we'll talk about in detail how the data will get exchanged. And last will be which direction we are heading with all this information and everything. So this is what I'll be covering. Moving forward. So to see what is IoT. Okay, so a simple thing to answer would be that it is a collection of methods using which we make devices accessible through remote connections to be controlled by people or to get data from it. Okay. So simply put, this is what it is. So if you just ask me that was this not available earlier, I would obviously say that it was available earlier, but this was not a specific solution or a more sought after solution till then. So I have seen people who are working on similar kind of solutions in whatever different segments where they have tried to create grab data through wired connections, wireless connections from the devices, and then try to make sense out of that data. Let it be just for accessing it or let it be for control. But specifically Internet of Things or IoT came into picture where they want to categorize this one as a specific solution, industrial solution or a solution required for all the purposes, and categorizing it and seeing it as a proper discipline where more time has to be invested to get the details or to put more engineering resources to get a commercial out of it and everything. So in this one, Internet of Things, when they say devices are nothing but things. So why is it called things and not devices? Is it might not be just a device. So it can be something that is already integrated as part of your information. It can be something patient data when you say there is no thing, right? So there is information out of it. So there is no device specific. So these are the ways they have classified it and they called it as things. So this is what, simply put, trying to get access data from different devices and making sense out of it is what Internet of Things should be. Okay, moving forward. So earlier, the nearest competitor that came into picture was M2M, machine to machine. So what happens between these two is quite different. So here in IoT, is there no machine to machine? Yes, there is interaction between machine to machine. When you consider IoT as a node where data is grabbed from the sensor and then it is sent to the cloud through the gateway, and then on the other end you have a server sitting which will grab that information. As long as this is there, if you consider these as machines broadly, yes, there is interaction, and from there whatever control or smartness that you want to add on top of it, when that comes into picture, how you want to take a decision out of it is what makes a difference. Okay, so machine to machine specifically is about multiple machines talking to each other to define or to get information about each other's capability or each other's action, where the dependability between the two machines will be available. Okay, so for example, robot 1 and robot 2 in an industrial setup, where robot 1 is supposed to do some action and only after that the robot 2 should start. Okay, so this can have a machine to machine communication, and to let robot 2 know that robot 1 has completed the action and 2 can take over from that, so that there is no clash of either or weight of and everything. So these are the places, and this M2M is predominantly controlled to proprietary based protocols and softwares and everything. When it comes to IoT, it becomes more important because lot of open standards and lot of open implementations, okay, lot of different discrete components who can play a major role in each and every level are coming into picture. When I say that one, so a lot of bodies who are governing how things should happen, when they started entering and started dictating terms, so there can be multiple segment of people who can contribute towards this with their own expertise. For example, the server side and everything, or the cloud side, there are experts who are capable of giving this information completely. So these guys can come into picture and then start providing their own specialized solutions there as platforms. And there are people who are capable of making very fast and very capable routing capabilities and everything inside a gateway, and then they can come in as an independent actors into this whole integration. And then the device guys who specialize in specific kind of devices, they can play a separate role. And these can all guys sit at a different independent level where they can provide information. In M2M, it is all controlled through one side where the manufacturer himself provides all this information, and he has his own proprietary methods of grabbing this information and everything, and it is for a more closed kind of environment and everything. So this is where to differentiate that kind of an closed environment with an open environment, this IoT concept came into picture. Where if you ask me that is there no proprietary or closed stuff inside IoT, there are proprietary stuff as well, but equally there are good amount of open standards also and protocols that can be implemented, and that in itself guarantee lot of data privacy and data security as well as data transfer with a minimal data loss and everything. So specific protocols for such kind of things have been defined. Okay. Moving forward. So to give a rough reference model, what was given out by ITU. So we have multiple layers acting in any of the IoT device. Okay. So you have something known as a device layer, where what kind of device, what kind of sensors that it picks, what kind of data that is supposed to pick and everything. So this is applicable both from the IoT node. Okay, what is an IoT node? To answer that question, IoT node is a device which will have either sensors or connected to the sensors. So these sensors can be, for example, if you take farming, it could be soil data sensor or weather condition sensor or plant sensor, plant related information sensor, or you might have any kind of other sensors which will take which will be getting data about water level inside a container and all these things. From industrial perspective, it can be other sensors like proximity, movement. It is trying to find out what is the shape of the devices through a camera, and all these things can be devices. So in this one, so these are the kind of sensors that you might have along with the node or can be connected to the node. Okay, node is the endpoint device in the IoT infrastructure. So sensors become external to the IoT infrastructure. Node becomes the endpoint, and node has device layer where it is more of hardware level, what kind of hardware connectivities and everything that comes into picture. Then it comes to the network layer, where what kind of connectivity that it wants to use to connect to the next level as well as with the previous level. So when I say previous level, again we talk about this one, what to say, sensors, or we talk about having access to the cloud and all these things. So then comes the service support and application support layer, where what kind of generic services that you are supporting. Okay, each will define that one. So when I say, why I'm saying multiple services here, is that you have some standard services, some proprietary services. So what kind of device is connecting through what? So there can be a multiple of this, which is available on the node, which makes it more special, where according to the usability, that specific method of connectivity and services can be used. Okay. Then here comes the application layer, which will define what the data usability and how they want to integrate this information and send it to the next level. So this whole thing is like a pyramid. So what happens is at the device layer, you will have its own set of communication methods. Then you come with the network layer, where it comes with its own defined methods over that communication method. So for example, if you take the example of an Ethernet cable and Ethernet connectivity is standard, but on top of it, the protocols keep changing. And from that perspective, if you go to the top, what kind of generic service that you will allow over the Ethernet, data transfer, what kind of data transfer, TCP, UDP and everything comes into picture. And then on top of that, you have specialized protocols which will use this TCP and UDP to send data over it. And that will be there. And one of them is physical Ethernet cable. The other thing will be the wireless methods. So that comes into picture. And then you have application layer, where a lot of information of what data to be sent. What is the processing that is supposed to happen on the data? Should it happen on the device level itself, or should it happen at the server level itself? So this comes into picture. So same architecture, if I use it for IoT gateway, then gateway level, the capabilities changes. Okay. So what we are talking about is about capabilities where you have device, its own connectivity and everything. Then you have what kind of routing that you are supposed to do, what kind of information that is coming from the nodes to the gateway, and how to use that information and how to take it further to the connectivity. So connectivity can be multiple there. It can be cellular, it can be over Ethernet again to the internet, or it can be intranet. Okay, there is other methodologies also which they are using, not just cellular and everything. Other wireless methods are there. So this is there. So you have application capabilities like how it is said, service support, and what kind of services that you are running on top of it, and how much you will support, where the restriction comes and everything. So network capabilities, device and gateway capabilities, as I explained, how it can be restrained over a device, okay, to a IoT node, and then IoT gateway, how it will be there. And then between the different kinds of nodes, how that management would happen, okay. And then what is the security required at each level? When you say that you are having multiple pieces getting connected, one can inject an error which can pass on and compromise the whole device. So how do you take care of that one? So these are the things that people have started talking on and started concentrating on beyond connection and everything. Okay, moving forward, typical IoT setup, when you say you have a device which you are, or you have a parameter that you are getting through the sensor, which is available to you through an IoT node. Okay, you pick that value, you send it to the IoT gateway. So IoT gateway would receive that information. So this can be wired, wireless, any method. And then you have a router part. So inside the IoT gateway, you have two major segments. Okay, one part is about receiving data from the different IoT nodes. And then the next part is processing, after processing, sending out to the server side. How do you send? So server can be remote, server can be local, any of these things can happen. And through that one, you send it to the server side, where the data either can be only for data collection part, or and then projected out as required, reports and usages, or you can run an analytic side on top of it to make use of the information of the data. So this is also a possibility. So then how do you present it out? It could be only reports, or will it be through control, access and controls that you allow out of it? And how much is the smartness that you want at each of these components? A gateway can be much more smarter. A node itself can be much more smarter. So this is known as edge analytics now. So where do you want to add more smartness in each level will enable each of these devices to become either a mere data collection device to a very smart device which is capable of taking care of it. Okay. So to give you a typical example of what is just a data collection unit and everything, if you are talking about any kind of water quality sensor that you want to use, you just want to check whether the quality of the water is good or bad, and then that typical data is pulled out and given. So where can that be used? In fisheries. Okay, in fisheries and in hydronic farming and everything. Okay, so or water, water supply board and everything. So if the quality of the water changes, then how much it has changed. So that whole data you just collect out of it, you take it to the server, and in server you have either a graph plotted or some over a period of time how the quality has degraded. So if you are doing a reverse study, if you are doing any kind of water source study and everything, so this is something that can be used. The other side, if you go, edge, this one, where you are using camera kind of a solution, you have a smart camera sitting in, which is, when I say smart camera, what exactly I would say is that it is capable of finding out whether something is happening in front of the camera. Okay, when I say something, so most of the CCTVs and everything now, what you have the capability to detect whether there is any movement in front of the camera. If no, then the data may not be sent. So that becomes smart by itself. So you save internet usage there. So you would detect that one, and if there is a immediate movement or change in the scene, then you take that information and you can also try to find out what is happening on top of it, okay, through AML, find out who is there and what they are trying to do. And then using that information, you send that whole data and whole found out information about the scene to the server, okay, where server can take appropriate action of calling people to find out whether something which is not acceptable is happening, or it can be something that, okay, there is a known person, so let them in, can become an access part where you allow through the server or through mobile, okay, where you allow the person or any kind of door unlocking and everything can happen. So this is the complex, one of the complexes. The in between you have like different segments what was told. Automotive segment, how it would work, that is totally different. You have different kind of examples coming in there. So this is what is in a nutshell what IoT is trying to do, and where and all places where it can be used extreme. Okay, so before we get into further deep into the IoT gateway part, I want to know if somebody has any kind of doubts here from the previous session or from whatever I showed now, so that we can go further. Okay, so continuing. So exactly now IoT gateway. So what we are trying to do. So what is the ecosystem that is looking from the developer's perspective? What is available? How things are there and what we are trying to solve here. So when you see from that perspective, so you guys are able to hear me, right?
Yes, sir, we can hear you.
Oh, okay. So just let me know when things get very bad. So I'm sitting at a different place where suddenly there is a lot of noise entering in.
No, this session it's a lot more better compared to the previous one.
Oh, okay. Thank you. So yeah, so getting back to this, so IoT ecosystem, what do you have from the developer perspective and whoever is making devices? So you have multiple components available here. So if you see, let us come from right side where the things. So these are the devices. So the ecosystem has been through using open people and open set of open source people and open contributors. So mainly from the Arduino and Raspberry Pi community. So these guys started giving out information on what is possible. Okay. From that, lot of experimentation started, and from there we have dedicated companies now getting into picture and already deploying solutions. Okay, so and the chip makers have started seeing this as a proper business channel as well. So the discussion when it started about internet and everything, they were talking about millions and billions of devices getting connected and everything. So this can happen only when there is acceptance of the technology. So what we are seeing is that we are at a stage where acceptance and customers are coming in with lot of requirements, like how we saw the previous discussion. There are discussions of why can't we get this data, or why can't we start controlling that kind of an device or an event where it can be much more profitable to as a community or for a specific cause and everything. So farming is one place, transportation is there, logistics is there, healthcare is there, and device on the vehicles is there, transport. So that is where it comes into cars and everything. And fleet management is one more segment that is there. And then security and surveillance is one more place where it is happening. And then generic use of cameras also, where attendance systems and all these things are coming into picture. And then much more smarter devices where people want to control what actions are happening, okay, or not let anyone get into a place where something which is not unacceptable will happen, okay, blocking them at that level. So these are the multiple places where IoT are playing IoT whole as an infrastructure is playing a major role. So device level, if you see things, so there are a lot of sensors coming in, sensor integrations are coming in with already available protocols. So when I say already available protocols, we'll see next what kind of protocols that we are talking. So all these things are already, which is available as a legacy till now, are being connected now as a device, and then data is being collected out of it. So this can be just on a lab today, and when that lab discussion happens at some places like how we are discussing today, so people are able to visualize that, okay, I can make use of this information as a whole to control or to become a value for the whole solution. So these kind of environments have started budding up, and it is growing now. On the services end, so all these devices and everything and gateway and whatever we are talking will become at one point. Where it is more useful for all of us is how we can connect it and get data out of it. So that is where services come in. Amazon see it as a major business case here. Google sees it as a major use case here. Microsoft sees it at this, and ThingsWorks is a very big place there. So these are ThingsWorks and Amazon, Microsoft, and everything. These have been the old players. So the rest of them have joined recently. When all these big names are coming in, it means that there is revenue for them. They don't want to. Nobody does anything for charity. So that is very clear here. So they see that a lot of devices when comes into picture, how all of this gets information and how it can be routed, and so much data can be used, so much data can be given. So each of these services, IBM or Microsoft Azure or Amazon, if you go, after collecting data, how you make use of that one, there is a huge cloud infrastructure in the behind. When I say cloud infrastructure, what I mean by that is, once you get data on that side, how do you want to process it? What and all processing that you can do? Where you can run just reporting, where you can want to collect multiple different kind of such okay, and then how do you want to make use of it? How do you want information that you get over it? So these are the places where lot of investments are going on. Lot of places are seeing that there are devices and specialized solutions are being created from the software inside the cloud infrastructure. For example, Amazon has a lot of things known as DynamoDB, where they have a database system, Lambdas, which are for giving out a lot of logics and everything. Kinetics, I think Kinetics it's called, where a lot of information is processing can happen. So these are components inside the cloud itself, where they provide a method where you can connect each of this and then run it as a proper server itself. This is from the Amazon server segment. When you come at the back end, where you are trying to use all of this information to regular processing, what we are seeing is that on a regular server architecture, where you are connected through HTTP or any kind HTTP or HTTPS and everything, you can use these protocols to send data from devices on your regular server. On top of that, you can create much more sophisticated data there, and then make use of the information as a okay. So this is some place where we are seeing that lot of information are getting exchanged. Okay, and then what you are trying to do is that level very inside the device, and infrastructure is supporting that one to collect that data, and you can send that data to your mobile phone as well. So these are the places where a lot of these big players are coming into picture. Now, seeing how everything can happen and everything. So you have this standard phase of development that you have. You have an idea phase and then prototype phase. How many type of stability and iterations come into picture, and then you go for deploying. When you go for deployment, who and all are playing, and then what is the scale at which they want to. If you see, so these guys, when they are trying into going, so these are the companies and standards that are playing major role here. Okay, so Wi-Fi and Bluetooth are being major backhaul, and then Ethernet also is being the major backhaul. Cellular data is there, and then in the prototype phase you have LTE support and Wi-Fi support and everything to connect to the backend servers and everything. Then you have all the different players coming into picture in the deployment and everything. Large scale deployment when you see AT&T comes into picture, Telefonica, and then you have all our web service providers and everything coming into picture. And they come with, they are talking about volumes. They don't talk about one or two numbers that we are talking. So when you're trying to control a very large space and then trying to gather that information and then deploy. Okay. So this is the ecosystem that is getting built. Okay. And most of it is in place now. So this has been brewing up and happening unknowingly from more than 10 years, but knowingly it's more than 5 years now. Okay, where people have seen this one, people have deployed it, people have found issues with each of these standards. Okay, why would someone come up with a new standard and everything? Is only because that there is so much different set of things that we are trying to deal with. Okay, so every specific solution is solving one information for us. Okay, one issue for us. Okay, so yeah, I just want to stop here before I enter further into it, so that you guys can get more digestion, information digestion about this one. Okay. So if you guys have any doubts over this, you can ask me now, or we can wait for further. Okay, moving further. So connectivity. So what kind of connectivities that we are looking from each of these gateways? Okay, so what we are talking about is...
So can we have some questions?
Yes, please.
This is Balchandra from KL Institute of Technology.
Sorry?
This is Balchandra from KL Institute of Technology.
Yes, sir.
Yes. So we are talking about IoT ecosystem.
Yes.
Can we predict something like in future the things will be plugged into the physical body, like our human body systems is there. Things will be plugged into our human body systems, and most of our physical activities will be controlled by IoT. Can we think of something like that?
Sir, control is a place for human body or any kind of animal is a very non-allowed method as of now. So people are not allowing that to happen. So because the film industry has shown us very good kind of movies where such kind of things are happening. But on getting data, I would say that we are working with a few companies, okay, a few research institutes as well, where they are trying to get information about body, specific information. So, for example, there is a project where they are trying to collect data about heart rate. This is not as a MI band or any kind of Fitbit kind of a story. This is about a proper placement of ECG patches and then collect data. Okay, they are trying to see whether they can get information about heart. They are trying to see whether they can get information about your breathing and everything, and use that information on the back end for research purpose, at least to start with, and later this can be deployed at either each and every patient level, where post surgery or anything, surgery or treatment, okay, what is the continuation of the treatment that needs to happen at home level is tracked, okay, and if any kind of anomaly is found with respect to the conditions, then immediately the doctors or the back end, the hospital can take care of what is going wrong, and they can reach the patient faster. So this is there. Okay. So, and there are other projects where for prosthetics, it is one of the major places where it is playing. So, where people are trying to collect data here and then want to use mechatronics to make prosthetics for people. So, this is
Yes.
also there. Okay. So,
Yes.
this is all controlled
Yes, sir,
from the human.
because why the question is like this? Because in services we have
Mhm.
so many available services like ThinkSpeak, Microsoft Azure, or AWS IoT solutions. Whatever
Correct.
you are talking, no, almost all these are ready now. So
Correct.
the healthcare system, uh, agriculture system, so many things
Correct.
are ready.
Correct.
Now few things are there, like whatever we are not able to apply is the size and the way actually how they have to be plugged,
Correct.
into the system. So in
Correct.
that order,
So that is
so
where
because
now.
you have opened the very interesting chapter like IoT ecosystem. Like
Correct.
we used to consider the ecosystem in the developments for humanity development.
Correct. Correct.
So
So
that's why actually
this
the
is
question
where what
raised.
we are seeing. So that is where what to say, when Amazon and Microsoft and every are coming in, they would come in with their own vested interest, right? So each of them will be doing through their own interest. So there are entities which they want to do good to the humanity. The other guys may not be very much interested in doing good to the humanity. They are looking at more finances level and everything. This, when you say ecosystems, I am not including here the standardizations that's coming in. Okay, that is where this security and standards and standardizations from all the governing bodies who are into information security, who are into what to say device security, who are into device capabilities and everything coming into picture. So they, when this whole ecosystem is growing and generating revenue, the data is also coming in. So what will happen to that data, right? How is that being used? Whether it is something that is used against the people or whether that is being used for the people. And what is the, what to say, laws that are coming in internationally? We are not talking about national laws here. Internationally, what is being accepted? Which direction we are going? So there is multiple governing bodies which are coming up with at each level and each layer. Okay, so they are standardizing few things and they are bringing standards saying that what should be allowed, what should not be allowed, okay, and how much it goes. I would not say that people would 100% follow everything and everything, anything, but when you want to do, see, one or two people trying to do a extreme level of research and extreme level of control and everything is different. And then deploying it across a multi-space and everything, and creating a solution and making money out of that is totally different. So, for example, when you want to do any kind of a solution and if you are not complying with any of those standards already set, right, you will not be able to go and sell whatever you are trying to done and everything. For what is the use of doing it, right? So such kind of dependency starts coming in. So governing bodies are in place now. Earlier when it started and everything, people have taken it not very seriously. Okay, when the usage has increased, a lot of governing bodies, they have been discussing from quite some time on how things should happen and everything. They have become more vigilant now and they have started seeing that how things can go in a wrong direction as well. Okay. So they are coming into picture and they are defining things, what are the things. So that is where this whole next slide where we are seeing what are the connectivities and everything, what are the different protocols are coming in, how data needs to be used, misuse and everything. For example, one simple thing I can say, you are talking about human body. Let us take smart city and everything. You have streets and everything, you have access to all camera data and everything. It can be used in multiple ways for crime, right? So how that should be stopped? How such kind of things should be controlled? Okay, these are the places where a lot of research has shifted now. Okay, and deployments are starting, and developments and deployments are starting now. So does that answer your question?
Yeah, yeah, it's an open question.
Yeah, yeah,
We'll
yeah.
find it. Yeah, thank you.
Sure. So anyone else?
Sir, are you touching about blockchain also in this one?
Blockchain as such, I'm not touching it, but we can talk about it. I'm
Yes,
open
yes,
for it.
yes.
Yeah, continuing. So on the IoT connectivity, so this is with respect to the gateways perspective when you see what and all it will try to connect with. So if you see on the other side, you have device coming in where different kind of sensors, when we say end sensors or data providers will come into picture. So it can be an RFID, simple as RFID tag. It can be an embedded mobile and mobile phone. So these two are totally different things. Okay. So what is embedded mobile is? Embedded mobile is a kind of a device where it has the capability of mobile phone minus the smart features or the features that you have in all the mobile phones. For example, you might have internet capability, but you have a browser and all these things, right? So some of the features which are not required with respect to industrial requirement or the specific device requirement are stripped off. So something like take the Android, remove unwanted apps out of it, and even remove the home screen out of it. But it has rest of the capabilities on the back end, which is not available as part of your UI. So that is coming into picture. So these are the things. Then you have the mobile phone, which is our standard data. For example, how you connect. So you have solutions where you connect, the breath analyzer, or you have your, pressure analyzers, and then you have temperature analyzers and everything that you connect to your mobile phone itself through USB OTG cable or through different ports that it supplies. So using that one or a wireless device which is connected to the mobile phone through which you are trying to get your fingerprint scanners or anything, all these things connected through the mobile phone and sent to the gateway. So this is also a possibility. Then constraint device with radio is having a device through which you have different kind of RF capability coming into picture, where it can be low band RF and everything. That is getting data for the local network. So it can happen that you have a small, environment where multiple things are kept and you are getting all that data over your mobile phone itself, and your mobile phone may become the end device for you. Okay. So this is all a possibility, where how small it can become and how big it can become. Okay. And then you have sensors coming into picture. So you have positioning and temperature and different kind of sensing like room temperature sensing, room quality, air quality. You have different when you go for industrial side, then it can become the belt water chain and belts that are being used, how it is a industrial maintenance of the motors and everything can come into picture. Okay, preventive maintenance is one of the places where it is happening. So all these things become the sensing parts for you. And from the human perspective, temperature, heartbeat, whatever is your conditions, so everyday monitoring. Okay, so that can happen. So blood pressure, and usually when you go, you take blood pressure and you take sugar data and everything. So this can become an oximeter functionality. This can become a everyday functionality that you already have. And you might have data along with you when doctor wants to access that one. He can access over a period of time. For example, let's say 1 week or 1 month or 1 year, how the fluctuations have been and everything, so that he can diagnose it better. Or he knows the previous history better, which you can't express it when you go and sit. You can't tell day by day activity, how much it went and everything, unless you have maintained a logbook. So these kind of information that you can make use of it. Then you have communication side, where device communication can happen as an RFID, you have Zigbee, infrared, Bluetooth, Wi-Fi. There also you have, or Ethernet level also. We have power over Ethernet features also, where your gateway can power your node also at the end. If you don't have power capability, no battery and everything. So these kind of devices are also being used. Okay. And then on the identification side, biometry and video. So you have iris scanning, you have fingerprint scanning, you have video-based and face recognitions coming into picture, person identification, person action identification. So this and all is coming towards the AAML part and everything. But are they not available today? They are available very much available in sophisticated surveillance methods and everything. But whatever was available in a sophisticated surveillance method is now slowly coming towards regular things also. Okay. countries which have put this one and extensively using, you also would have heard and known. We have seen in China this is happening. Okay, so at least on the camera side and everything, the surveillance systems are much stronger. So they see what is happening at each and every nook and corner in the city. So it is very much there. And in Europe also there are places where it has been deployed and everything. So systems are available. How do you make use of that system is something that is dependent on your country's policies and country's methods. Okay. So a country which can use it for detecting, tracking someone to one extreme of the use case to finding out if there is a mishap that has happened and reacting to that very fast. So that is also one more method that you can look at. So these are the things that happen. And next is localization and tracking. So this is for fleet management, transport, and then even tracking also coming into picture, where you're sending, like when you say fleet management, like for example, we have VRL group or groups which are having their lot of this one. So for example, in the bus segment and everything, right? Our Karnataka or the state government road transports and everything. So these guys can use such kind of information of tracking their vehicles, where it is going, what kind of situation it is in, and then get data out of it, and then try to see that how they can maintain a better quality of the buses, okay, better rideability for the users, okay. They are providing services, and that's how quality can be increased. And once the quality is increased, then you have a homogeneous kind of solution available, okay. For lorry services and everything, they can track their parcel better, where it is going, how it is going, and if there is a mishap for the vehicle, who should be informed? Central guys who are responsible for that company should be informed, as well as the technicians need to be informed. Roadside assistance need to be provided, because if, for example, let's say Ashok Leyland and Tata vehicles are there, so nearest Tata dealer should be informed for immediate attention towards the technical support. Local authorities need to be informed if there is a requirement for that one. So all these things can be integrated as a whole solution. So that comes into picture. Okay. Next comes the security side, where you have message security and authentication, authorization, and privacy. So these are quite different topics. So data that is coming in, how much it is secure, or what kind of usage of that data is happening, who can read it, how you're restricting it is one side, and then what kind of privacies that you're allowing, or who is only allowed to use it. Okay. How much data can anyone get into it physically itself, how you are restricting that one. So these methods are also coming into picture, and what kind of authentications are supposed to be done to access that data. So now what's happening is, even at different levels, you have security coming in, where you are using secure tunnels and secure sites, secure methods, where you are accessing through two-factor authentication, and then there is this one OTP based or QR based, and all these things are part of our security. Without knowing, we are using that one in all our payments and everything. These are the methods through which different kind of securities are being enabled for us. So these are the different, when you see one solution, for example, taking a fleet management, and what is his end goal, okay, to make it a better service to the end customer, how he tracks it, how he is able to do. And was it not done till now? Yes, it is done. It is not that we are doing something new. Only thing is, we are making it much more accessible to them. When you have small service and everything, it doesn't matter here. When you have 100 lorries running in, right? To maintain that one, the amount of people that is required is one thing, but the amount and the way data exchange between the people when it happens, right? What is the delay that it adds, or what is the kind of data transformation that happens? Person to person, when the data moves, the perception of the data changes. So end of the day, the top guy sitting there, if he wants to take an information of what is happening today, how many things are broken down, where his investment should be, whether he should work towards better devices or better maintenance of the vehicles, then his budgeting and everything is dependent on all this information. He gets it only quarterly. Okay, what if he is able to get it monthly and everything? He can plan his budget better. He can pitch for different extra budgeting, or he can look for what else he can provide as a solution, how to increase his revenue and everything. So these are the places where information once gathered can be used. Now to gather that information, how it would help is coming back, we will let us say that on vehicle tracking and everything comes to GPS and GPRS. Vehicle movement is being tracked along with that, your parcel is being tracked, use RFID inside that one. Okay, vehicle, each and every parcel is being tracked, and then each and every devices there is a camera in front of it. If somebody is stealing it or somebody is not stealing it, all that the information is captured, and then along with it, you store all this information, send it to the backend for processing. So they'll be looking, so when there is a breakdown of the lorry, okay, breakdown is different, accident is different. When you see breakdown, you have that problem, so that can be identified and that can be informed to everyone related to that. When there is an accident, local authorities are coming into picture, then technicians coming into picture, then what is the alternate for that vehicle to transport the goods, right? So all these things comes into picture as an use case if you see. And how that is done? Through these IoT gateways and IoT devices and everything. So you have the gateways which is capable of pumping so much data to the cloud and connectivity, providing connectivity always, okay, and capability of being alive. So whenever, even if power is there, power is not there, battery device. So all these kind of solutions you can start putting in with respect to each and every advancements that we see. The more the compact battery that you have, the more power we can give to the device for longevity. Okay, so along with that, you have better modems coming in. So you have the modem which is capable of always getting connected. Okay, so all these solutions, tiny things which will fit in to make it into bigger things. Okay, so any questions on this slide or till now? Okay, moving further. So threats, where and all threats can happen in IoT. As I was defining, so this is one of the examples where you have different kind of data transfers that is available, and each and every level, whether it is physical or wired or non-wired, okay, you have places where it can be, the data can be misused. Okay, so when I say what kind of things, so for example, over the network, when you see on the bottom end, okay, so you have at each and every sensors, when the data is coming itself, the data can be corrupted at that level itself. Okay, so this can be not an intentional, but at a grassroots level itself, there might be a error in the device itself, because of which you are getting a corrupted data. So, or that information is being tapped and taken away for some other usage. Okay, so that can also be a possibility. That is where we see a threat on how to identify whether the node or the sensor that is connected is broken, or how it will, how to identify whether it is working or not working. So that comes into picture. And then you have MQTT and XMPP and all these protocols coming in. So where they are trying to define, okay, over the cellular network or through Ethernet or wired Ethernet or Wi-Fi and all these things, where you have that these protocols sit on top of your TCP and UDP protocols to give a better data compaction, okay? Because end of the day, if you are using HTTP and everything, there is a minimum size that should always go, okay? So irrespective of how much you send, rest of the packet is filled with it, and that is the standard size that will go, okay? So because of which the usage of bandwidth is high. End of the day, how does it matter is when one or two transactions, nobody cares. What if you are deploying a device where you have hundreds of devices and adding that much, and that will end up being using your total data availability using any of the service providers. Let it be Reliance Jio or Vodafone or Airtel or this one. So in Indian infrastructure, if you go outside the US and everything, AT&T and everything, so Verizon and everything, they charge as per the data size and everything. So these guys are playing major role. So how do you decrease that one? How do you bring data compaction and everything becomes more important? And these are the places as well where you can attack this one and see how the data can be compromised at that level. So that is also place and then you have it at, as I said, Zigbee, Bluetooth, Wi-Fi, and everything. These are the protocols in which you can pull data outside. Okay. Why do you want to pull and everything? Some may do it for fun and some may do it for a requirement. Okay. For when you say fun, if it is just some farmer and farm data is going on, nobody cares. But what if that farm is controlled through one of the multinational company who is trying to get a survey of what is data inside, what kind of produce that it can get in, and if there is a competitor who wants to make sure that your estimations should go wrong from this level itself, that can become a threat for you. Okay, and then GSM, GPRS level 3G and everything, there also you can go. So that is internet connectivity and everything. You go to the free data, free transmission level and everything. So once you go there, what kind of securities are being added to that level? How the data is being used. So these are the places where it can go. And the other side, on the server side, HTTP, which is using REST APIs. So how is that data that becomes more important? What kind of attacks that can happen there? How can you corrupt, mimic data, which is not actual data, to go into the server and then create a wrong estimation of the input that has come. Okay. For example, on the other end, you might be like camera and everything, you are expecting, you see that physically there is something, somebody is intruding into the fence. And then, but the information needs to go to the device and it has to go to the server where it has to alert the individual or person available for scrutiny, the security officer, and as well as the local authority as well, that something else is going on because he needs a backup. But what if somebody has hacked into it and showing that nothing is happening, right? So this is also a possibility. So these are the places, and then once that information is done, for example, if somebody is viewing it remotely, so there also to your mobile and everything, the threat can be, the information can be misled, misfed, and all these things can happen. So these are the places where threat is a possibility. Okay. And what kind of information? Why are we saying threat is a possibility? Is somebody has played around with that, and that is where it is never a proactive, corrective measures that will be taken. It will be a post-threat corrective measures are taken. Otherwise, we would not have our antivirus and everything, right? So everybody takes that way. So as the people who are fixing these issues are trying to make sure that these issues don't happen, there are set of people who are trying to find out these loopholes and making use of it for their own or for their clients' usage. Okay. So these groups will keep growing. You cannot stop it, and you cannot say that you will have a very good environment. Ecosystem-wise, they will grow in their way, and because of this, other side also will grow. So this is available, and this is available today. This threats and everything is available today. How do you take care of it? So where this plays an important for you, from the device level, from your gateway level, from your node level. So these are the places where we give more importance in developing a device. Okay. So this is where we see that what kind of solutions are available. As an individual service provider, what can happen, and what can happen for a different level. Okay, so this is what is multiple things that we will be looking into. Okay, so moving further.
So,
Yes,
sir,
please.
how blockchain can be introduced in this IoT for the security? Can we get some sites on
Yes.
it?
See, blockchain's basics are mainly about one entry and no modification, right? So that is the basic idea with which blockchain started. So if you talk from that level, whatever entries that are made, if no further change in that entries are allowed, okay, and then all the data is available, but you are not, your only possibility is accessing that data and making sense out of it, then that is a place where blockchain as a technology can help you. Okay. So for example, Bitcoin came into picture. Bitcoin tried to pull blockchain and it became a very big hit. Now how it uses is, it makes up ledger maintenance and all these things, where it becomes very easy through the blockchain. Otherwise, the way it happens is in your implementations, you have places where it can be modified or what is that, changed data can happen over a period of time. So that is not allowed when you bring in the blockchain security. And then along with that, blockchain small basic concept around that one, lot of other changes have started happening because there is interest growing out of it. And because of that, they are using that blockchain method and securities and data management in the blockchain, how it would happen, to control the amount of data that is coming in, as well as how the data is being used. So if you ask me
how do you predict that this blockchain may be introduced in the IoT? What will be the...
See, it is all on implementation level. When you say implementation level, it would be in the solution providing of, let us say, if it is coming into the farm sector and everything, how much data that you are using and what kind of information that you are integrating becomes more important. Okay, and how critical is that? So country to country threat, if you are seeing level, all information regarding of farm predictions can go wrong, right? So can be manipulated. So there, if you want to control that one and everything, using a blockchain and technologies around it, you can control saying that whatever data that you have, because it is all based on previous data that you will try to do, or the stock market when you see. Already what happens is, you have a lot of history data on which the current predictions will happen, right? So history data should not be lost and history data should not be tampered. So this is where the blockchain technology becomes very important for such kind of solutions, where history data becomes very much important. And even for the research segment and everything, you are more dependent. All your algorithms and everything works based on your previous data. Nothing will predict the future without having previous data, right? So such kind of places, this becomes. So now solution-wise, how, if you are asking me what will happen and everything, this is all integration level that each and every solution specifically solving what critical data comes into picture. Okay, so that is where everything is going on.
Okay, sir. Okay, thank you, sir.
Okay, yeah. So any other doubts? Okay, moving further. So edge computing. So this is also something that is getting very much traction in the industry now. So this is also getting implemented inside both at the IoT node level as well as IoT gateway level as well, along with the server side. So edge computing or AML can happen at multiple places. So cloud, and then what happens on the device level is called as edge. Okay. So on the cloud side, you already know that AML have come into picture, right? So they are doing processing of the data and then taking decisions from there, and remotely that is happening. So now edge came into picture where we want a swift action to take place, and nothing is getting changed. Okay. So when that is happening, what happens, what is changing from the device perspective, the amount of processing that is required by the device is increasing, because you have a predictive mentality or predictive methods of algorithms running on top of it, applications running on top of the devices to take swift action. For example, if you take farming setup, where you see that based on the soil, so you have methods where you have containers which is filled with nutrients that is required for the soil and everything, and you are connected over that one, and you, through your sensors, you pick the values, and based on the values, if you feel that any of the nutrients that is missing need to be supplemented, then the device locally can take care of that action and send the information to the backend saying that, okay, if the reason there is an action taken for the specific reason. Okay, and what is the action taken and what is the reason because of which that action was taken can happen. Criticality level, so that is also constructed. The other place is, for example, fence and everything. So electrification or solar fencing is one of the things where it is used in forest departments and everything. So regular fencing and everything is okay, but we are seeing that a lot of people are using direct to 50 volts and everything there. So it can happen that whenever, through the security surveillance cameras and such kind of setup, what can happen is whenever a threat animal is observed, only then the solar fencing or the minimal current fencing is enabled. Otherwise, it can be disabled. Okay, save power through that one. So this is also one of the methods. Water can be one of the places where, based on the water level and everything, you can do a smart, filling of the cans or the overhead tanks and everything. So that can be informed, and water seepage, water wastage and everything can be tracked, saying that from point A to point B, if there is always seen a water loss and everything. So that information can be obtained, and then informed to find out why that every time water is flowing between these two, point A and point B. So these things can be done. How it can be done is through providing flow sensors and everything. Then you get data out of it and send it. So you have a local gateway, or which is also an edge gateway, and which will track that one. And if there is an issue there, it will intimate to the server saying that something is going on here. Or if it is not smart, it will always keep sending data to that one. So imagine the amount of information that gets transferred always. So that should be minimal for us. So that is the problem that these kind of solutions are solving. And in the camera wise, if it is tracking a person and everything, so if a person, specific person needs to be tracked, so that person is like information is fed everywhere, and it finds out where the movement of that specific person is happening. Okay, so best conditions it would pick, and based on that on how quality of the image and how it is used and everything comes into picture. Attendance management system, where it is based on camera. Okay, so edge computing is one of the examples there, where you have that when the person comes in, he's identified as a specific person, and then that data is there. And as a report, only the text report is created, which is enough for the end server to have it. It need not have everyday's image and everything. Image becomes very high data and everything. So such kind of places, this edge computing is coming into picture. Now, a dumb device which is available on the farm, where it is supposed to just get the data and everything, may not be edge device. But at the gateway level, where the whole farm can become autonomous, semi-autonomous or autonomous, can be one of the places where it can become very important. Okay. And then when you come into higher security levels or attendance and finding people and then tracking your deliveries and all these things comes into picture, it becomes more advantageous because the amount of data that you are transmitting from your device to the server can be minimized based on the conditions on which the edge device is built. So these are the places where edge computing has become much more prominent, and we have seen that in when the pandemic started, there were a lot of requirements from edge computing end that started coming in. Okay, people wanted to track their employees' timings as well as their setups with respect to places where it is much more stricter. So a lot of facilities are there with which people are tracked on what kind of activities they do when they are working and everything, and they are in a much more stricter conditions because of the kind of criticality of the data that they hold with. So such kind of one of the firms we were discussing, and we had provided a solution where they started talking about wanting to track people and then find out how what actions they do and link it with specific acceptable and unacceptable actions. And such kind of solutions have come in. So that was one almost like a high-end technical use case for us. So such kind of places, such kind of requirements have started coming in, and people are seeing a possibility of realizing that on what they have heard of or they have seen over in the silver screen. So these are the places that we are seeing that lot of traction happening and lot of developments going towards. Okay, so any doubts till now? Okay, moving forward. So now with all this information that we tried to establish till now, when we say what is the role of gateway, what is gateway and what it does and background information, what we see is that the role of gateway is mainly towards integrating multiple connectivity options at the cloud or server level into the device, okay, where the high-end, high processing unit is able to communicate with your low end or low processing unit, which is capable of collecting data for you and as well as doing some some actions which gives it additional information at the specific outpost where you are looking for data, and then sending it to the server. The next point is it can connect to multiple nodes or sensor, which has active access to sensors to get information, and that connectivity can be varied and multiple. So when I say multiple, what do I mean by that is that you are connecting from the node perspective and sensor. You may be connecting over Wi-Fi, ZigBee, and RFID, and RF signals, low RF signal based communication, some proprietary communications. All these things come into picture, Ethernet based communications. And when you say higher cloud server options and everything, you have cellular data, you have Wi-Fi, you have Ethernet, regular Ethernet backend. So, and then you have satellite based backends also direct. So all these things come into picture. Okay. And then importantly, so whatever data is collected, making sure the data is not tampered, and then you're getting data as is to the server. Okay. So to the server or to your processing, so that it can help in not wrong predictions as well as mispredictions also. Okay. And not jeopardizing and screwing up the whole system for which it was built for. So that becomes one important this one. And then add more smartness into the devices itself and using edge analytics support, so that it might not become just a dumb data collecting device or just a device through which you can enable, disable, or control a little bit, okay, remotely, but also take some kind of preventive actions or identify things which are not easily identified from the human end. Okay, a threat, something that will happen, or any kind of difference in the whole data that you are seeing can be identified from it, and it can hint you saying that, okay, something different I am seeing. So then it becomes the role of the person who is taking that information physically to find out whether that is an acceptable data that's coming in or unacceptable. And if he has to take an action over that one, then he has to go ahead with that. So these are the places where the whole role of IoT gateway has been evolving. So earlier it used to be just an internet connecting device where you get all this information, throw it through the internet and give it. Later it said, okay, we want control over the devices. So it became a duplex path where you are allowing the devices to be controlled remotely also. Now I will be bringing in a little bit more smartness and everything. So with this, what happens is the kind of requirement for device capabilities changes and where it can be used, what it can be used. Now, as I showed you the ecosystem, a different set of guys are preparing different set of things. For example, one set of companies are creating the devices and sensors and all these things. The other set of companies are creating gateways. The other set of companies are working towards providing you services like Amazon, AWS, and Microsoft Azure, ThingsWorks, Google, and everyone. So these guys, when they are not from same ecosystem or same kind of alliances or companies, they tend to bring in their own ideas and they want to make things better, or they want to show that they have better technology and everything. So such kind of clashes, to minimize, they have to agree upon a standard level of operating between each other, so that when that standard operation methods and everything are established, more vendors or more kind of suppliers on both the ends can come into picture and provide a better service. So end of the day, the whole system will become much more better, okay, and much more secure, because each will survive through his own unique selling opportunities or unique selling methods, okay, where they might be giving a better algorithm, better timing, better solution. All these things come into picture. End of the day, the users of the IoT, okay, will be more beneficial, will get more benefit, will be the beneficiary for all of this information. So this is how the ecosystems and the role of gateway changes for us. Okay. So moving forward, now where we are seeing and what kind of hardware capabilities that we are expecting. Okay. So usually IoT gateways are categorized can be categorized into three. So one can be low end, mid range, and high end. So low end and all, you have microcontroller based categories where we see that it may be running a firmware directly or a simple RTOS also, and where there is very less data that is required, and the cost is less, and it needs to take only small amount of data, where it can be just a collection of data sending to the main device. Okay, so it can be over Ethernet, it can be over backend different methods that you have, wired methods, and also it may also process where an additional module is available, which becomes your connectivity, router connectivity for Wi-Fi or through wire or through cellular and everything, along with the microcontroller. So you can create one device like that, which is having a very less capability, but still sufficing all the requirement. So why would that be required? For the cost factor as well as deployability factor. So you are deploying it at a place where smartness is not required and everything, and easy replaceability. So that becomes more important. So such kind of places. Now mid-range NAC, these are the places where you see that, okay, a little bit much more powerful device is required, which is capable of handling multiple little bit of actions on the other end. Okay, remote access can be one of the places where you access the device and take a specific action. For example, Ring is one of the companies where they try to access whenever somebody rings a door, the camera is started and all these things. So these mid-range of devices can become a low-end device where you have a low FPS, low resolution cameras that are sitting to just identify who it is and then allow them to access or not be accessed. Okay, or you can see that RFID card based or app based inbound vehicles and all these things. So where you have an app based connectivity coming into picture. So these can be sometimes low end because when you are connected, when you are near to the device, it can be connected over Bluetooth, it can be connected on local Wi-Fi itself, and then that action can happen. So these kind of things will sit into the mid-range, and the high end comes into the more powerful device where it can be multi-core ARM or x86 based architectures where it is able to collect data and then handle high data traffic where it is through mesh networks or different kind of thing, collect large amount of data and then do a processing on top of it. And then that processing might be time critical because of which a specific priorities have to be given for the specific applications and rest can be on the back end. And all this data at the end of the day, because it is huge data stored on your local drives, and then that needs to be given to the server for processing, or a further processing of that same data can happen at your end, and then you are sending the data to the server. So that is the high-end segment where you see that how the IoT gateways play a major role. Okay, so moving further before I stop for Q&A. So software level. So what is the standard or minimum requirement when you say from the software level? So it falls into something like this, where you have a small hardware. On top of it, you have regular firmware or a RTOS, real-time operating system, or a standard operating system like which has Linux kernel comes into picture. Okay, so or you have a Microsoft-based architecture also using WinC and all such kind of things, Microsoft kernels. So come into picture as operating system. So on top of that, what are the other software modules that will be required? Is sensor stacks that you want. So if you are connecting over ZigBee, BLE, Wi-Fi, Profibus, Modbus, EtherCAT, all these things are with respect to each segment of industry that you are working with. So those software stacks need to be available with you to connect, or a specific module should be available with you to connect with that stack. So that becomes more important. And then on the other end, if you see its own connectivity methods, right, over HTTP, this one, to say HTTP or MQTT or COAP, WebSockets, okay, WebRTC for this one, RTSP, RTP for camera side and everything. So these are the protocols that have been established and found to be working good with respect to that. And inside that you have, if you come into camera segment and audio segment, you have different kind of compression algorithms coming into picture, H.264, VC coding, okay, and then MPEG-4 and all these things, and then you have AAC, MP3 coming on the audio side, packaging that one into MP4 format, AVF format, and everything, and then you push it over the stream to the other end for the other end to take it up that video segment and then do any kind of processing or storing it for further usage, because this device, IoT gateway, wherever you're deployed, if it is damaged, then you have a backup of the data. So that all things. And then these gateways connectivity on the back end to cellular network or wired Ethernet network or Wi-Fi network. So that is also, those stacks also need to be available either as a router device or as an internal within the gateway itself. So any of this is possible. Then you have FOTA, where the firmware update over the air is a method where without the device getting plugged out or removed, you update the firmware of the device and then you enhance the capabilities or any kind of bug fixes or threats that you see further. Okay, because once deployed, for example, if you are putting it in your backyard or in your house and everything, you can remove it or plug it and do it. What if you have deployed it something like in a field or a farm, okay, or a bigger factory and everything? You can't go plug in everywhere. And if you have put it into a remote place where, for example, if you are tracking something with your mobile towers, you can't go and if you have placed it on some hill, go there and to update your firmware, right? Connect it and bring it down, connect it, and then switch it on and everything. So that is where this over-the-air update options come into picture for you. And then security. So if you are connected to all these devices, how it should be secure? What if somebody opens the box? Okay, how much data he would get? And what if he is not opening the box, but he is connecting an alternative wire? He's created a physical hack into the wire to get the data of the communication. What if he is connecting over wireless network to connect? And then what if he is connected through a different kind of device and then trying to mimic things? So all these things come in for the security side. And then device its own management methods and configuration. What are the facilities that the gateway allow? What it will allow for configuring things. So these things come into picture at the bottom level of the software stack. Next you have top level software which will take care of data management. So once I get this data from these different methods which are software below software layers, how do I handle the data? Okay, whether I store it here, along with that, do I package it in a different way? And then using which method? For example, video data. Do I encode it? Will it be H264? Will it be VC coding? Or will it be H.265, MPEG-4? And then that is become data packaging. Then you have putting it into an MP4 format. That becomes 10. So that management, after getting the data, what I will do with that data? Will I store it locally? And will I also send it to the server? When will I send it to the server? How much data will I capture? So that becomes as part of custom applications. But all these facilities should be allowed by this data management team. And then cloud connectivity and manager is connectivity in itself. Like I have access to this connectivity. For example, Wi-Fi comes into picture. You have to connect to the network. You have to give authentication and all these things. So that becomes independently available for you. So these kind of things come into picture, and then custom application. So this whole gateway device can be head or headless. What do I mean by head or headless is you might have a display or a LCD, smaller green color LCD with only characters, or a graphic LCD like how our mobile phones look like, to give what is happening inside or to show some data. It can be any of that device, or it might not have any LCD at all. Okay, just a plain device which is capable of doing everything but doesn't have a user interface. So it can be any of those devices. So such kind of variety of combinations in hardware and software can be created for a specific requirement to cater and to strengthen the device. Now, where does this whole thing go towards is? These are all driven by what kind of device that we are making, what kind of costing for which we are making, and what kind of data security for which we are making, and what kind of data that we are handling. So all these factors become the challenges for creating such kind of a device, and how efficient you can make it. Because in this whole thing, if we say that it is powered through a battery, the whole understanding of how we do it changes for us. Okay, it should be more efficient. It should be more to say robust and less power consuming. All these factors come into picture for hardware design as well as software design as well as software architecture. So such kind of factors govern how things should happen. Okay, so this is just an overview of how software things are there. Okay, so yeah, so gateway wise, and so this is gateway story. And coming to the node and device level, you have such capabilities with removal of, let's say, the cloud connectivity part is removed, but you will have on the other end the sensor stacks and everything, where you have a Zigbee based device with the sensor as a IoT node, which is capable of drawing information from your physical space, okay, and then converting it into a Zigbee data and sending it over a Zigbee mesh to you. So these are devices or IoT nodes, what we call it. Okay, so these can be any of this. It can be a BLE device, it can be a Modbus, EtherCAT device, okay, or Ethernet device or Profibus device, and you have LoRa device and everything coming into picture. Okay. So device-wise, the capability reduces. It is made for a custom requirement, and it is supposed to work as is, and it might have that it is having battery, or it can happen that it is running over power, connected power always. Okay. So this is how the whole system-wise, on the device-wise, if you see how we categorize or how we understand the IoT devices. So any doubts till now? Okay. So if you guys get any questions in between, you can stop me. So moving further, IoT integration types. So when we say integration, what we are talking is how we are integrating our devices with IoT service providers like AWS or Microsoft Azure or Google or ThingsWorks and all these guys. How we integrate, what kind of methods are being followed in the industry. Okay, so this is a singleton kind of a architecture where we say it per silo integration, where each device is connected to a specific platform. When you say platform, it is on the server side that we see. We call this as a platform. So you connect each device, for example, your power meter or a vehicle or farm device gateway. So all these things. So vehicle side, it is called as a different segment itself. It is called telematics, where you are able to start your AC, your engine, your different kind of devices internally, heaters and all these things. So for specific at different ends and everything, and then diagnostics of what is happening to the vehicle, how much power consumption is happening for this. And even with electric vehicles coming into picture, this whole game has changed to a different.
How many slides are there?
Sir, we have 27.
Till 27?
I'm at 18 now. Yeah. No. I think I'm at 18, so 2, 7, 9 slides.
Anil, how much time we left?
Sir, we have to break out for a lunch, sir.
Maybe 10 minutes you can close?
Sure, sir.
Pritham, let us close in 10 minutes. Is it okay?
Okay. Yes, I can.
1:30 will break. Yeah, 1:30 will break for lunch. Yeah.
Okay, sure. So yeah,
Continue.
so what happens is you have single devices connected to the platform on the server side, and then single services are provided. So this is one of the methods where individual service providers or individual integrators are coming into picture, where they take specific data, connect it, and then give it out. So what is the problem is it does not allow you to scale or integrate with the bigger picture, and limits the evolution possibilities inside this whole platform. Okay. So you have next method, which is known as integration platform based, where you have a common platform built and you can integrate all of these devices to the same platform, and each data can be derived out of it and make it. So who are these guys? ThingsWorks is one of the places where which I have discovered and worked with, who have capability of this. They try to connect with multiple things. So they were in the vertical segment. Now slowly they have started becoming a complete common platform level, where they are trying to allow you to integrate all of this and derive data accordingly. Okay. So this becomes in evolution of the whole architecture and everything, and move it into a top level. Okay. So use cases level, if you see, so very top level, if you say, there are few kinds of use cases, you can say, categories, you can say. So variable IoT is one of the category, where like how we were discussing earlier, right, the human level and everything. So you are trying to get data over of your vitals, and then you are using it through the IoT network to provide services to the end user. From the end, if you say a small baby management, you are seeing that there are a lot of premature babies and everything. They are kept into separate contained areas and everything. So that needs to be tracked. And how much ever you are keeping a specialized person to look after it, they want to see that whether they can go further and then track things so that no mishap happens. This is one end. The other end is the elderly people who are at old age homes, or who are at your regular homes, who have devices which are connected, through which you keep monitoring them of any kind of mishap, okay, of any anomalies in their vitals, or if they have experienced they fall and everything, if they require help. So earlier you used to have large families and everything, or somebody would be there to take care of it. But going towards the nuclear family and all these things might be affecting it or might not be affecting it, but much more accessibility and safeguarding that segment is also important. So that is where hospital systems and everything are coming towards also, to find out that how they can help on that segment, to find out how they can solve the issues. Okay. In between, you have for sports training person, how to track that one, how to track their progress and everything, and people who are trying to maintain their own regular segment and physics and everything. So for them, how to help it, and for people who are post-surgery and pre-surgery conditions and all, to track their vitals so that they can be taken to the surgery and how they are tracked and everything, and also giving a remote facility where person can have that one over a kiosk and everything, and he just plugs in himself or connects few things to himself, and through that one, a remote doctor can diagnose his situation and provide him some suggestions based on it, whether he can go for a primary health center or a bigger hospital and everything. So these are the places where variable IoTs are playing into picture. Now going further, in transportation, when you see, transportation can be fleet management, can be regular public services management. It can be your specialized services where car and vehicles, personal vehicles come into picture, how they are managed and everything. So each and every device, like how Sir said, LiDARs and different kinds of body ECUs and everything are coming into picture, where they want to track what is the kind of situation that it is there, whether within electric vehicles you see, or diesel vehicles will see, whether there is a maintenance required for specific parts there, how it is performing, and when there is a replacement from the manufacturer and because of various reasons, how it is behaving and everything can be tracked. And if there is any error in that one, how it can be called in for replacements or this one, because that becomes time critical for them, and as well as critical human life and everything. So transportation and regular public services, where it is going, who it is going, how many people it is taking, what is happening there, how much it can be taken care, what kind of situations it is in, if there is an accident, or if there is a junction or a jam where it can move in. So all these things can be tracked. And logistics and fleet management, when you say, the example of lorries and everything comes into picture, where you're taking this into a different management of data, parcel services, and all these things come into picture. So these are the examples of different places where you can use this combination of nodes, gateways, and everything. So transportation, when you say you are talking about mainly on the wireless side, so you use cellular data, and how much data you want to see. Do you want a live feed of camera? Do you want a stored feed? Along with that, do you want to keep tracking your device, small containers inside the vehicle that you have it, or you want to see who and all are sitting inside the bus and identify them? All these things comes into picture for us. And on the personal vehicle side, drowsy detection, and if person is driving and he's feeling sleepy, then how does it park and everything. So Mercedes already has this information, but how to bring it to the masses? Mercedes cannot be only the guy who has it, right? So how can it be brought to the masses through a better method or a lower cost version with the same safety standards and everything? So that is where it is. And one good thing about Mercedes is whatever their research and everything is open for everyone to use. Okay. So such kind of facilities, once they take the lead and they let everyone else also use, and such kind of things can happen. So going into the farming segment, as we discussed earlier, so integration with the weather conditions, market conditions, market availability, and then your situation, soil conditions, and everything. Suggestions the whole institutions, agricultural institutions can be integrated in such a way that based on soil conditions, what is best to be grown in that soil can be suggested. And later, once the growth is happening, it is being monitored of the growth and everything, where people need not go to the land to monitor that one. That expertise can be held at some other place, and the person is able to sit at his own institution and then monitor that whole thing, along with physical visits and everything. And later, once the things are in the right state and when they are harvested, a marketplace integration to give the sale for the farmer, so that the whole issue of growing, maintaining, and then getting the right value for that produce is also covered in that. So in each segment, you can have a lot of sensors coming into picture, a lot of data integrations that can happen at the service and cloud level through the applications, and mapping through the satellites imaging, and then you have controlling of that, and then taking this data on a scientific basis, how we can do, and weather condition changes, how it is impacting and everything, you will be able to track. Okay. So along with that, the bigger thing is smart city. Now, when you say smart city, you are bringing in a lot of IoT devices into the picture. So when I say a lot of IoT devices, you have your street light management, you have your water management, you have your power management, you have your traffic management, you have your safety, physical safety management. Okay, you have tracking of people within that premises who is not from the same place, and then you also have about waste management. So all these places, each and every devices can bring in a difference of how things are handled, how to keep it as a better hygienic place and everything, and how we can make it into a secure place.
Preetham, 5 more minutes.
Yeah. So where we are heading finally. Okay. So with all this IoT, what is happening is we have collected so much data, and now that data is either stored at your server level or at your device level. You have some pattern that you have generated out of it. Now, what will happen out of it is you have started collecting a lot of legacy data, and what was known to you over a period of years, over the books and physical survey and everything, is now you are able to get it with these IoT devices at a much more faster and a more accurate level. Now, much more research will go on towards how to make things efficient, better, and for a better produce as well, better results as well. So how this data will come to you, what you will do with data needs to be decided, and what all different methods that you can integrate multiple data information like weather information, produce information, soil information, water information, and everything, and how do you club to make it into a better usable solution becomes important. And different examples whatever I gave. So this data and how securely the data is not is coming to without getting tampered also becomes important. So that is also one of the methods where we are heading towards. So earlier it was about collecting data. Collecting data has started now. How do you make use of that data to make things better for you is the solutions that we are working. Now next is more important of how we can make sure that the data coming is correct. So that is where we are heading as of now. Okay. So this is the place where I would stop. And yeah, I am open for any QA as of now.
Hope there is no questions from the audience. And sir, can we break for a lunch?
Yes, please. Let's go.
Sir, we are extended for 15 minutes. Shall we start the next session by 2 o'clock?
Yeah, yeah.
Okay, sir.
2 o'clock, okay.
Thank you, sir.
So half an hour break, right? Yeah.
Yes, sir.
Okay, thanks, Pritam.
Yeah. Thank you all.
Thank you. Yeah.
Dear participants, we are breaking out now for a lunch. So we will join the next session by 2 o'clock. Thank you.